Good afternoon and welcome everyone. My name is Danielle Stackis and I'm the Associate Director of Alumni Relations at the Robert H. Smith School of Business. We're excited that you're able to join us for today's webinar, From Data to Decisions, Analytics in Today's Business World, presented by Stephanie Bauer Marshall of M3 Advisors. This webinar is part of the Smith Office of Alumni Relations Professional Development webinar series, in which we hope to provide thought-provoking and valuable content that will help alumni like you achieve your personal and professional goals. During the webinar, we encourage you to use the chat box to share any questions or comments you might have for the presenter. Feel free to submit these throughout the session and Stephanie will address them at the end of the presentation. Stephanie is an industry-recognized leader in successfully bringing digital advertising, mobile marketing, and big data monetization products and services to market. As the founder of M3 Advisors, a boutique consultancy, she advises early to mid-stage startups and association clients on how to define, position, market, and evangelize new products and services. Stephanie spent a decade in leadership roles at Verizon, where she created the company's first mobile ad targeting programs and led Precision Market Insights, a business segment she incubated and launched in 2012, which is now part of Verizon's Oath business. She is a 2000 MBA alumna from the Smith School and currently serves on the corporate advisory board at the school. And now we'll get started. Stephanie, take it away.
Sure. Hi, everyone. Stephanie Bauer Marshall, and I am excited to be here and share sort of what I know about data and how you can use data to make decisions. I'd like to preface it first, though, that I am not a data scientist. I'm not an engineer. I'm on the business side, and I love working with the super smart data people that can help me find the answers to questions using data. I'll never forget when I first joined Verizon, they said, hey, go figure out this mobile advertising thing. I always realized that the value in the advertising was the data from mobile. And so I'd started my career early in wireless, and I'd done a PowerPoint, because that's how we did business at Verizon, is everything's in PowerPoint. And I'd had this, sort of an atom-looking thing with, all these different data points that a carrier could have with a chief data science in the middle. About 8 years later, we finally got a chief data scientist. And I was so thrilled because I could literally go around and say, hey, we have a rocket scientist on the team, because he came from NASA. So that's sort of my background, and I'm not going to go deep into the, data analytics pieces of it, but more about the applied uses. And so as we preface that, I'll get started. Let me make sure I can, why isn't this working? Hold on. I might have to do it this way. Okay. So data is not new. It's been around for a long time. I mean, even going back to 1865, where we found the first use of business intelligence by a banker named Richard Miller Devins. He had written a encyclopedia of commercial and business anecdotes that leveraged the term business intelligence. Fast forward about a century later, 1958, IBM, which we all know is probably the grandfather of data and analytics, coined the term business intelligence as the ability to apprehend the interrelationships of presented facts in such a way as to guide actions towards the desired goal. And I thought that was appropriate because it really is looking at different data sets and figuring out what is going to help you get to that goal. And I'll talk a little bit about that later. Since then, obviously, the data types and tools have evolved. In the 1990s, we had a lot of enterprise resource platforms, decision science systems, or decision support systems. Online data came into play. So when you think about the internet and the data that created was huge. You had people like Oracle, SAP, IBM evolving, Microsoft, and goodness knows there's a whole host of others that have created tools to help with different data types. What's most exciting to me was the new sources of data. So online, as I discussed, and then mobile, which really, I think, opened the door to what we now call big data. and those data sources come together to create that perfect storm. So if you think about web usage, social data, cookies that enable you to tie data to unidentified individuals or unique individuals, application usage from mobile location, which has really opened a treasure trove of data that can be tied to, again, device IDs. And then the startup that I did when I left Verizon was in the IoT space. And so that particular space is driven by sensors, and there's just so many sensors. I think IDC said that there's going to be 20 billion of them by 2020. And so that all of those things are generating just an immense amount of data. So what that leads to is like really, 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 really big data. There was a slide, I was trying to find it, I'd done ages ago for a Verizon presentation and couldn't find it, but I found this, which is a good representation of how fast data is growing, right? If you look at just the business data, so thinking about, CRM and things like that, sensor data, which is probably about 50 times that, and then human data, so what we're creating ourselves, it's growing exponentially. And so we're moving past what originally was zettabytes to yottabytes, and most recently I'd heard the term brontobytes, but there's even talk about creating a new term called hellabytes, and it stands for a hell of a lot of data. And so that's where we're going with all this data that's out there. But before we go too deep into how we can use all this data and leverage it to make decisions, I wanted to just level set in terms of what is it really, what does it mean? And there's a fairly defined term around what constitutes big data. It has three basic components. The first one is volume. So obviously I think that's pretty clear in terms of big, how much data is created and collected. So for example, the volume of CRM data or social data or data from all of the different sensors that are out there. Then there's the velocity of the data. So how often or how quickly is the data created and collected? And more often than not, we're moving towards near real time or real-time data collection and use. Variety is the different amounts or the different types of data. So how the data is formatted. Is it email? Are they financial transactions? Is it numbers, dates, letters? And that data can be structured or unstructured. And I'll define that in a minute. So I'm sure a lot of you, and I looked at the attendees, and it's hard to tell kind of how deep you are in big data or how much you know, but wanted to level set on some of the terms that are bandied around. And some of these are buzzwords, but they really do have meaning. So structured data is data that's within a fixed or defined field, right? So for example, data within a spreadsheet where you can have name, address, etc., or data in a relational database. So for example, a CRM system. So that's structured data. And it sounds like what it is, it's structured. Unstructured data is data that doesn't really have a predefined data model or a set organizational structure. So for example, email, there may be some of you may have very organized email, some of you may not, but email in and of itself is not structured. There's a lot of text within it. Same thing with social media data. So there's a lot of companies that are out there mining social media data, as well as things like videos, right? So how do you start to use metadata to classify videos, like looking at even down to companies that look at the words that are coming and the images, visual image recognition from the videos. And that's very highly unstructured data and requires different tool sets to be able to even collect and analyze and organize that data. Then there's what you do with the data. So predictive analytics is the use of advanced analytics to make predictions. So you take generally the structured data and unstructured data and deploy analytics to look at historical data and make a prediction about the future. Some of that is done using artificial intelligence. So the ability of a machine to perform a task in a way that mimics how we think, right? So how humans think, so cognitive function. And then machine learning, which is very popular. It's I think I read an article where I think every single startup in the world is using the terms artificial intelligence and machine learning to describe what they're doing, at least in the media and entertainment world, that's true. Machine learning is the application of artificial intelligence, where the machines can learn from data given to it without specifically giving it specific instructions. So a lot of times what we'll do is use data to train the machines to do certain tasks. And that's something that we definitely used at the startup that I was in, the IoT space. And a lot of folks are using it. It's very common. So what do you do with it? There are so many use cases, and I was working on this presentation, and I was trying to, there was no way I could list all the different things that you can do with data, but I tried to categorize them into a couple of different high-level categories. Business intelligence, which I started with, and really all of this is, I mean, the intelligence aspect of it flows through everything here, but answering a business question. So one of the things we did at Verizon was, could you use location data to determine where to open a store? Or could you use location data to figure out who comes to a venue, right? Or what types of people come to a venue, right? For ticket sales, generally 1 in 4, 1 in 4 of who they are, but you don't know who the other 3 are. So could you say, they're coming from this part of the county, or they tend to be, males 18 to 24, et cetera. So those can be used to answer business questions. Marketing, this is not new at all. I mean, if you go back to direct mail and the catalogs that you get, they're coming to you for a reason. It's not spray or pray. You're getting them because of some action that you took at some point, or whether it could be just your age, gender, or zip, and how you fall into a certain segment. But the advent of online and mobile has opened the door for a lot of different ways to target a specific audience. And that's something that I worked on at Verizon, where we're able to target on mobile, of course, with all of the privacy controls in place and permissions, and that's something I'll talk a little bit about later. Security, so being able to detect anomalies and reduce risk. At the Startup Wireless Registry, they're using, or they could use, the IoT data, so signals over time from your phone, so Wi-Fi, Bluetooth beacons, to be able to look at patterns of identity. And so knowing that, for example, banking, right, for a cardless ATM or a keyless entry to a car, if your phone and your devices kind of detect something that's out of sync, then it may ask you for another form of authentication. Lots of companies, banks, et cetera, are using big data to detect fraud. It's probably part of the reason that you get an alert when your credit card detects something that's out of your norm. I got one last week or something, because my husband had gone to Houston and used our credit card and got denied, and they were going to shut it off. I'm like, no, don't do that. But it's good in terms of they have detected fraud before, and so that saves a ton of money for the banks. Health, this is something I'm super excited about, because I really do believe that big data, and when you think about the wearables that are coming out, the ability to use data to provide precision medicine, or to predict and influence more positive outcomes in the health arena. A company that actually invested in, called Kenzen, is leveraging sweat through it has a wearable patch that you use, takes sweat analysis to look at, biomarkers and biofactors such as, hydration, or blood sugar, or, different indicators, blood temperature, right? So they're looking at how they help with workplace safety. And so there's really amazing uses of data that I think are going to be extremely impactful to our world in positive ways. Of course, there's also sort of a dark side of it, and I don't know how many of you have heard of the book, The Circle. And I highly recommend reading the book, not seeing the movie, because I have not seen the movie, but I heard it was horrible. So highly recommend reading that book. And it scares me to death, but I also believe that, you know, a lot of times change in terms of data and how it's used in new technologies that come into place can be used for good and can be used for bad. But read the book, and if you want to talk about it anytime, I'm happy to. I love it. But anyway, there's a ton of use cases of what you do. So where do you start with all of this? I tried to simplify it, and this is, you know, a fairly common use of how you would describe it, but you always start with the question. So the definition: what problem are you trying to solve? What is the question that you want to answer? And what that does is helps you understand what's the right data that can help me answer that question. One thing I always like to emphasize is that the quality of data is important. So if you have garbage data in, you're going to get garbage data out, and that's going to influence the, or could falsely influence how, what you learn, right? I mean, I think there's an adage, you know, you can find a statistic for anything, and you know, you do have to be careful in how you craft the question and what data you use to answer it. And then from an analysis standpoint, and I'll talk a little bit about this too, but you really need the right type of people and the right type of tools for the types of questions that you're trying to answer. And there's definitely a shortage of qualified data scientists. I think that's changing because there's been such an emphasis on data and the future of it. But it is hard to find. I think a lot of organizations struggle with the getting the right talent in place. You know, the tools are all out there. I think just knowing how best to use them is the challenge. So, and that's why it's really not that simple. I mean, there are those 3 areas that you need to focus on, but I don't think everyone is quite, we're getting there, but we're not there yet. 95% of Fortune 1000 companies started a big data project in the last 5 years, but less than half say it actually achieved measurable results. And that's a problem, but at the same time, if you think about how you look at innovation, you have to try, right? Test and learn and not be afraid to fail. And so if you go in with that mindset, these companies are going to be further ahead than someone who has never tried at all. So 95% or 90% of the surveyed in the IDC Enterprise Data and Analytics Research Report said they ran into challenges. I think a lot of those challenges start with the question. I think some of it comes from culture as well. But according to Gartner, a lot of the efforts get stuck early on at the pilot stage. So why does that happen? Or why is it so hard? Storage is a big issue. Again, I think that's being addressed by some of the cloud and compression technologies and edge networking. Data is expected to double every 2 years. I mean, going back to that, the helabytes slide, that's a hell of a lot of data. And I think that opens the door for a lot of innovative solutions to come into play and how to address that. Data, more data is becoming unstructured, and then data silos, right? So if you think about an organization and where data resides, you may have some data in the IT organization, you're going to have some data in the marketing organization, you'll have data in the finance organization, and how you connect the dots on that data is difficult, not only from a technical standpoint, you know, security, privacy, but also cultural, right? So that's an issue. Movement, so getting the data where it needs to go fast and near real time. So looking at some of the edge networking and where you store the data and how you access it, you know, cold storage versus hot storage and things like that will influence what data you can access and how quickly. And so there's a ton of new companies that have come out that are trying to address that. You know, obviously Amazon Web Services is you know, working, and so is Azure and a lot of those guys. Google has their own cloud service that's trying to address that as well. And so lots of innovation happening in that space. And I'll continue to come down to this, but really it's about people. So both the talent that you bring onto the team and the culture that you create. So, you know, going back to what I just said about, you know, some of the troubles and challenges coming from the pilot stage, you have to get people aligned and behind, you how you approach, right? So the importance of like, why are we doing this? Why are we, using all this data and addressing concerns and getting people, data can be scary and analytics can be scary. And, I don't know how to do, put a Hadoop cluster together or run, regression analysis on, massive data sets, but you can identify talent that can and understand the questions that you're trying to answer and bring the right people along to help you answer them. But it's not all doom and gloom. So there are tools that are evolving to help address all of the things that we just discussed. So the storage of the data, the connection of the data, the organization of the data, how you access that data and where, Hadoop, Spark, like I said, AWS, and there's just tons of tools out there, which can be daunting. But also, again, having the right people that can help you pick the tools that are right for what the problem that you're trying to solve is key. Open source. So as open source has become very popular and accepted, it speeds the evolution. I remember just being at Verizon, like nobody, like IT would never, ever do anything open source when I was first there. And now, I think they even went to Google that. I mean, there's an evolution within the enterprises, I think, as open source becomes a more accepted way of working with code. Analytics tools are helping bridge silos. So even some of the, enterprise-based solutions are integrating analytics tools to make it easier for you to use. So a lot of companies are folks like even Salesforce and things are integrating analytics into their tools in ways that make it easy for those of us that are not the data scientists to pull out insights that are meaningful for our businesses. And of course, AI, artificial intelligence, and machine learning, while very buzzy, they are buzzworthy because they are becoming mainstream. They've been used for decades, and they've been evolving over the years, and it's becoming easier and easier to use. Again, partly because of the tools that are in place as well. And so no presentation is complete without one of these lovely little charts. So the big data landscape of 2017, as as I kind of, originally I was just going to throw a couple of examples up there in terms of the different companies you could work with, but this is much more comprehensive. Obviously, a lot of familiar names up there, some of which are in the DC area, go DC. But lots of so many different companies in terms of trying to help you manage and use the data to make decisions. And that is, I recommend looking at this guy's site, Matt Turk. He's got a lot of really good information on there. And it's sort of almost, I look at him as sort of the Mary Meeker. If you're in the media industry, Mary Meeker puts out an internet trends report that is, like God's word in the industry. And, this is a guy for big data. Again, I said this before, but it's worth mentioning again. It's not just about the machines and it's not just about the technology. You need the people behind it. And so there's a lot of folks that are like, oh my gosh, machine learning and AI, they're going to be smarter than the humans. And we're going to not have jobs and, the world is ending. It's not. There still needs to be people that are programming these machines and knowing what to do with what comes out of it. And so, yes, our jobs probably will change. But for today, I think, as I said, it's not so much the data scientists, which of course there's a shortage, but it's also the people that know what to do with the data. So the data translators are the ones that maybe, have a good understanding of data, probably maybe someone like me, where I know what goes into it. I have enough to be dangerous. I'm not sitting there writing, the code or doing the modeling, but I know what I need out of it. And I know what's important to the business. And so you have these data translators that are domain experts that can help work with the data scientists to translate it into things that the business can use. I liken this to, product management, where you have a product manager and a product developer or a product marketing person, and you're able to translate requirements, from, the technical requirement or the business requirements into the technical requirements. And so I think there's going to be an increased need from that. And you can find more information about that in McKinsey did a study about, I think, a couple years ago, maybe 2012, where they talk about more into, what's required there. So again, it comes down to the people. And so I wanted to share, I pulled out a couple of different case studies. I tried to be fairly broad in terms of the different usage. I could go on and on about all the different types of things you can do for marketing and for advertising, but I wanted to kind of show the different things that are available out there for different industries and verticals. So one use case that I found is insurance. So AIG uses big data to fight fraud, reducing their costs, increasing efficiency. And so what they do is they use a combination of structured and unstructured data, and this is very common. I think most people will absolutely be using both types of data. And then they use machine learning to parse out. So they're going through their claims databases and even looking at handwritten adjuster notes from insurance claims to tag claims that they think they should investigate. So they'll say, okay, this claim is, a high priority because we've picked out something that may indicate that there could be fraud. And so they've been able to, more efficiently operate and go through claims faster by, looking and prioritizing the ones that could be fraud. So that saves them money and time. They also mined text in over 10 years of claims to look at a correlation between claimant frustration. So I'm sure if any of you have filed an insurance claim, I hope you've had a great experience. I know I've had experiences where it's been a total pain, and not that I've ever sued anybody for it, but there is a correlation between frustration or frustrated customers and litigation cases. And so what they did is they looked at, they created a group to address it, which lowered litigation claims, which of course saves them, just a ton of money. And AIG is actually really, if you just did a search for AIG and big data, you'd find a ton of different use cases of how they're using data. And they've been doing it for quite a while, going back probably a good 5 to 10 years. So definitely look, if you're looking for examples or looking to learn from it, definitely check them out. UPS is another great example. When you think about the, logistics and supply chain, UPS is right at the center of that. They deliver about 4 billion items per year, and I'm sure that number is probably even higher with some of the stuff that they're doing with Amazon. I know they probably do about 100,000 packages to me every year, but they're shipping a lot, right? So any improvement in efficiency is going to make an impact. So one way they use big data is to optimize its fleet. So they look at telematics, which is, asset management or fleet management. So a lot of the trucks will have a GPS signal on it that enables them to map, look at the routes that the UPS drivers take, optimize those routes, look for the things that are most efficient over time. They can use sensors in the car to predict maintenance time. So we know that, okay, over time, these types of indicators are going to predict that this truck is going to need maintenance, so they can avoid some of that. So do some preventative maintenance and reducing idle time. And so when they're looking at all those things, they were able to save nearly 40 million gallons of fuel. And that's a lot of oil. And they've also reduced the amount of miles that they've had to drive, right? So there's lots of positive results that come from that, not just in money and time and business results, but also reduced carbon emissions. Automotive, another favorite area of mine. Ford's a good example of a data-driven company, and what they're doing is transforming their organization to be more data-driven. So their CEO about a year or two ago, who was former CEO, but he said, when you look at the business, we're not just car manufacturing, we're a technology company. And as vehicles become more connected, so as they're part of the Internet of Things, and with permission from the consumer, they're going to be an information company. A friend of mine just wrote a book called The $0 Car, where it kind of goes into some of this, but how can you use data and monetize that data in ways that help a consumer, right? So if you're thinking about, you can take out some of the cost of the vehicle, you could use the data to deliver a better service or prevent, certain things, but also using big data to reduce insurance costs, to improve transportation, look at driving patterns, provide safety features. And what Ford has done is committed to advancing their big data and analytics team. They've added 200 people to look at data to help them sell more cars, which is obviously something important to them. And then also looking at how they're preparing using data for the future of autonomous vehicles. And so when you think about sensors and smart cities and autonomous vehicles, all of that requires just a massive amount of data that's able to work together and work together quickly and in near real time. So over the next probably 5 to 10 years, even 20 years, you're going to see just incredible advancement in that space. A lot of the car companies have committed to autonomous vehicles by 2020, which to me is crazy because that's really not even 3 years away. It seems so far away, but it's really just around the corner. So we'll see how that goes, but lots of data needed for that to operate effectively. Another company squarely focused on data is GE. And so this goes back to sort of the people and the culture, right? And so when you're using data to understand what's happening, both from the consumer side, and so the former CEO Imlet, they basically said, look, I see what's happening on the consumer side. So you see that there's been consolidation around, Google, Facebook, Amazon, Apple, and, their valuations, they've kind of sucked up the entire market from a consumer standpoint, especially from an advertising and content perspective. But there's that data transformation that's coming or that is underway within the enterprise as well. And so in seeing that, he focused on sort of, what are the things that we need to do in order to change the culture to be more data driven, bringing on the right talent, providing retraining, and getting the company behind it. They also invested in, sensors, right? So analyzing this data from the sensors that they put in gas turbines, jet engines, oil pipelines, and a lot of that, you can look at in terms of, if you want to learn more about it, just look for the industrial Internet of Things. And they're going to, continue to focus on that and try to be a leader in that space. And their goal is to triple their software product sales to $15 billion in the next 2 years. That's how they're using data. And again, this is really just the tip of the iceberg. There's a lot of, and this is probably more of a sensitive subject, but how the government uses data. So IRS is an example that's lauded in a lot of different places in terms of fraud prevention, right? They were under a lot of pressure to reduce costs and have looked at how they fight identity theft, how they fight fraud, preventing improper payouts. And they created a system, a pilot program called the Return Review Program that stopped billions of dollars in fraudulent payments. I think it was about $2 billion. And they worked with different companies such as IBM and SAP to look at the advanced analytics. And this is what kind of got them into a little bit of trouble, is they're mining commercial and social data. So they're looking at, building profiles about individuals, and they were called out, and there's a paper that an academic paper that calls out, hey, we don't think this is very transparent, and there were some privacy concerns over that. So as you look at data, you always need to think about what data are you using, and do you have the right to collect that data, and then do you have the right to use that data in the way that you want to use it. I spent a lot of time at Verizon with our privacy team and our lawyers, figuring out the right way to do that and the right type of transparency, notice and choice to consumers, so that depending on what data you're using. I'm sure a lot of companies now have privacy officers or have had privacy officer for ages, but it's always good to think about that as you're crafting your data and decisioning. Retail, this is an area that's, I think you'll notice a lot of these areas are being disruptive, right? Automotive, retail, definite changes coming to these, are already underway in these industries. But Walmart has created an in-house platform called Polaris, and what they do is they mine all of the search data, so the semantic data, and they use analytics to go through that text to apply machine learning, and they look at how they can improve the search results or improve relevancy for their consumers. And what that resulted in is an increase of purchase rates by 10 to 15%. And when you take that and equate it to what it does for that kind of change for Walmart is billions of dollars. And so sometimes even just something simple as improving, search rates really does deliver incredible business results. Okay, this is another one of my favorites, mobile location data, and specifically around Foursquare. Now, a lot of this can be done with, there's so much mobile location data out there today, and some of it's good and some of it's bad. But what really impressed me about Foursquare is how they use the data to predict a couple of key things, one of which was the iPhone 6 launch. And so what they did is they looked at the location data from its location aware application, so Foursquare and Swarm, and they used that data to predict how many phones would be sold on the first sales weekend. So they look at, historically what has been the traffic or the, how many of these users have appeared at an Apple store, what frequency, that kind of thing. And then they were able to predict that, 13 to 15 million phones would be sold that first weekend. A week or so later when Apple released, they said they had sold about 13 million of those phones. And so they were pretty dead on there. And another one, they used location data to predict Chipotle's first quarter sales figures would fall by about 30%. That was back when Chipotle had the incident with their E. coli or whatever, or Listeria or whatever. They had an issue with people getting sick. And so Foursquare used location data to look at historically what it had been and then made some predictions using the data to see what it would be. 2 weeks later, Chipotle released their sales numbers and it showed a 30% loss. It was like dead on. I think they were at like 29.7 or something like that. And it came out at 30. And so the closeness of that data was, and the precision of that data was pretty impressive. And then this is another really cool thing. There's just a lot going on in the healthcare space. The Cancer Moonshot is the program that was started during Obama's administration, where they were looking at how they could use data to help cure cancer or to prevent cancer. And so IBM Watson is a good example. I was trying to find this article that I had read a couple years ago where IBM Watson was used to, there's a woman who is not responding to cancer treatment, and they used Watson to figure out a different path forward. And when they switched paths of a different type of treatment based on her particular case and her data, so her genome and things like that, they were able to have a positive outcome. So it's really incredible that this data can help save lives. One of the research programs that Watson did with a New York organization was they looked at what Watson can do versus what a human can do. And what they looked at is, Watson could do something within 10 minutes compared to 160 hours of human analysis to come to the same conclusion. And so that's really amazing. There's new drug uses. So big pharma companies have come together with a data sharing arrangements where they were able to share data across companies that led to the discovery that despermine, which is an antidepressant, had the potential to cure some forms of lung cancer. And without coming together with that data, that discovery never would have happened. So that's the thing that I think organizations, think of it as almost like credit bureau in a way. There's power of, the volume of the data and the cross section of the data that can yield new results. Personalized or precision healthcare. In Pittsburgh, they're compiling data from medical insurance records, looking at wearables, genetic data, and then other data to create a more comprehensive picture of the patient and tailor healthcare packages to them. So that's also, an area where I think we're going to see a lot of better uses of data to really have an impact. So I want to leave some time for questions, but some things that I think you need to remember as you're approaching how to use data to help make decisions is, making sure that you have organizational buy-in, right? You need to, provide people with the tools and training that they need in order to support the efforts, or at least understand what's going on and why. The next one is really critical, is what's the problem you're trying to solve? And I think this is very basic and fundamental. But a lot of times, you look at big data and it's, oh, wow, this is great. There's all this data. What are we going to do with it? Let's put it all here, and, not really know some of the questions that you're trying to answer. So be clear on the questions and define it up front. I think that will help avoid some of what Gardner said, were some of the challenges of in the pilot phase, right? And then, data is everywhere. It's, know what the potential sources are. Some of them are external, right? So, if you're in, marketing, you have, CRM data that's internal, and then you have external data that you can get from mobile sources. You can get from, demographic data from Axiom. You can get social data and look at sentiment analysis. There's a lot of different ways to tie in different data sources to help come with, better segmentation and better results for the business. And then, of course, again, back to the people. Talent is definitely hard to find. It's not impossible. Obviously, Maryland has an amazing program. You have the Quest program, which I particularly like. When you think about the data translators that I talked about earlier, the ability to have people who understand the data but also know how to use it and how to apply it to business settings is extremely important. So look for data translators or prepare your organization for that. Definitely plug in the Quest program. I wasn't part of it, but I wish I had been back in the day. But yeah, so that's kind of, that's really it. So I guess I will open it up for questions. I gotta look at where my thing is. I guess entire audience. I'm just playing with this here.
Stephanie, I can jump on. Thank you so much, first of all. Just a reminder to everyone, you can type in your questions in the little question section in the GoToWebinar software. And we actually have one here that says, first of all, thanks for the awesome presentation. These examples touch on a lot of different types of industries and problems. How do you see small businesses using machine learning to improve their operations?
Okay, I'm sorry. Where is that question? How can you use machine learning to what?
How do you use machine learning to improve their operations for small businesses?
So for small businesses, yes, I was almost going to put a slide in, like the difference between small and big. There's software that's more accessible, right? So like, not everybody's going to go to IBM and do a deal with IBM Watson. But one of the things that I've used before is Tableau, and you can import different data sources and start to do, it's pretty user-friendly analysis. There's, it's accessible. You can do like a free trial and test it out. And if you are a small business, it's not, you'd be using tools that have machine learning already built in. So something, like, even, Salesforce IQ, it doesn't necessarily have machine learning, but it's a way to organize your data and use it. It pulls in other data sources like LinkedIn. It pulls data across your organization, such as email, so sort of unstructured data, and tries to put it into organization. So there's definitely different tools that you can use to help a small business. From a marketing perspective, in terms of machine learning, or I wouldn't even call it machine learning, but I would just call, there's even in Facebook, you can start to use some data to do segmentation, to look at, targeting people within a certain radius or targeting certain types of people. If you're a small business that is, consumer driven or even, enterprise driven, you can leverage those different tools to do some analysis. So I would say, like, from a small business perspective, you're probably not going to be using machine learning the way, a technology company might use it. You would probably work with, companies that are systems or software that has it integrated already.
Okay, great, thanks so much. We have a bunch of other questions coming in. What would you consider to be the biggest risk in using big data in finance industries?
I guess I would say in my opinion, and again, I'm not a financial advisor or anything like that, but I would say there's two risks. One is the quality of the data coming in, and two is the privacy aspect of it. So, and privacy is just a risk across any of the uses of data. But from a financial standpoint, like if you look, hedge funds are just phenomenal. And one of the things that, we looked at when I was looking at, what are the business opportunities from a data monetization business in using mobile data, hedge funds were like, okay, great, we could use this data to understand, instead of like having somebody counting cars in the mall parking lot, you could use location data to understand, okay, what's the traffic patterns to, stores like Walmart, and then you can then, probably make a prediction about, are their sales going to go up or down? And so the financial services industry is definitely using this data. I think there's risk in probably in the execution of it, how you're analyzing it, having incomplete data, and that type of thing. Yeah. Hopefully that answers the question to a degree.
So another question, how does your organization handle the movement obstacle associated with quickly converting raw data to modeling data in a reasonable amount of time?
So I think that comes down to the tools that you're using. And again, I'm not on the data science side of it. I know that we really struggled to figure out ways to process the volume of data. And sometimes that comes down to knowing what data to use and what data not to use. I think some of the technologies around compression and edge networking or edge computing will enable the decision making to move faster. It's definitely something that I think, a lot of folks, like I said, Amazon, we ended up using, we had originally used some of the more structured type data companies to work with us, but we ended up, moving to more of a mixed model of, Hadoop with some of the more traditional, companies. And I guess, I would say like reasonable amount of time, depends on what you're trying to answer, right? Real time, like when you think about autonomous vehicles, it's going to have to be damn near real time in order to work. And so, some of that I think is not quite figured out yet.
Great. So another question here, the quality and utility of data is often inversely correlated with the speed and cost of data acquisitions. As a result, do you see companies defining what good enough data may be?
Yes, that's actually a great question. So when we were looking at the data, right, as a carrier, you have a certain percentage of the market, right? And so we didn't have, we had census level data basically for our, consumers, but we didn't have, the rest of the, the U.S. And so what you could do is look at, okay, well, you do some lookalike modeling or you do some extrapolation. And it came to a point where we're like, okay, well, it's good enough, right? Because it's still answering a question. And from an advertising or a marketing use case or figuring out where you want to put a store, that data is good enough, and you can make a reasonable and solid extrapolation against the, a very large data set, right? Like if you're looking at, comparatively to say, a Nielsen survey or, data that existed in, the advertising and marketing and even site selection world, like you're really looking at like panels, right? Or, panel data that's, hundreds of thousands versus, millions and millions and millions. And so I got into a little bit of an argument with my data scientist, because then my chief data scientist, because he's a rocket scientist, and I'm like, we're not launching a rocket. We're just trying to help guide a decision, a business decision. And so I say, well, it's not really rocket science. So I think it just comes down to how you're using the data is determining what is good enough. And for advertising and marketing, I think it's definitely the 80-20 rule, for sure.
Okay, so we'll take 2 more questions here. One person again says, great info. I'm stuck on the operational side of collecting and managing data and am swamped daily. How do I better prove my value? An example was find time to learn software, or the Python.
Or Python, yeah. That goes back to some of what I said about talent and people and culture, right? If you're in an organization, and again, it depends on your organization, but knowing that the world is going in that direction, and I remember trying to get one of my old bosses to pay for some of my Maryland degree, and I just wanted him to pay for one course that was like relevant to what I was doing. It was strategy and wireless related, and he was like, well, you could just leave after this. I was like, yes, but would you rather me learn this and apply this right away, or would you, but you'd pay for an Excel class? So I think you have to think about, how do you position the value of what you're learning in the time that it takes to, of how that's going to save you time later, or how it's going to improve, the outcomes for the organization, and, make a business case, right? Anytime I wanted anything internally at Verizon or anywhere, you think about, okay, well, I know it's the right thing to do, but why is it good for my organization, and how do I convince others that, that this is the right thing to do? And so, knowing that, you have to think to the future and innovate, I think that's how I would, position it.
Great. And the last one, for our alumni who have children who are looking to go into pursue careers in data analytics, what courses or majors, just on your advice, would you recommend that they pursue?
Well, I think I said this earlier, but I mean, though I did not go into it myself, I would absolutely hire someone from the Quest program, because I do think that, depending on what you want to do, but I've read articles where, you could, and even actually in the Harvard Business Review, they called out University of Maryland's analytics program as sort of a hidden gem. And so I think any analytics or business intelligence type classes, I think part of it's also knowing how to use the tools, and not necessarily, I don't think you always have to go into a coding class, right? I don't think you always have to know, that underlying thing, but I think knowing what data is out there and how you can use it. And that's, I think, what I like about the combination of the engineering aspect, or the data analytics aspect, and then the business side of it with the Quest program. So I think there's going to be, again, I'm going back to that need for the data translators. It's not everyone's going to know what to do with the data. And if you can understand it enough that you can pull out the insights that matter, and cut through that noise, that's going to be valuable for businesses. And I think valuable as a degree.
Great, thank you. And someone in the audience is a Quest alum. And that's, for those of you who don't know, that's a program at the Smith School of Business at the University of Maryland, primarily undergrads, but they do have a graduate level version as well. So All right, so
Maybe
Stephanie, is there anything else you wanted to cover before we wrap up?
No, just thank you all for joining, and I hope you got something out of it. And if anyone has additional questions, feel free to reach out.
Great. Well, thank you, Stephanie, again, and thank you, everyone, for joining us today. We hope to see you at the university's next webinar in a couple weeks. Actually, it's next week, Year-End Charitable Tax Strategies to Help You Give More Without Donating More, which is happening Thursday, November 16th at noon Eastern. A recording of today's webinar will be emailed to everyone and posted on our Smith School alumni website as well. Hope you all have a wonderful day, and go Terps!
Thanks.